Commutative and associative properties. You have 4 of these to go through. Whenever you have to write these out, you can abbreviate commutative with this, and you can abbreviate associative with this. The commutative property of addition. The commutative property of addition says A plus B can be written as B plus A. That means if you have something like 5 plus 3, that is the exact same thing as 3 plus 5 because it still gives you 8. The associative property of addition says that if you have A plus the quantity B plus C, you can set that equal to the quantity of A plus B, close the quantity, plus C. So for example, if I had 2 plus the quantity 5 plus 6, I could do it as the quantity of 2 plus 5, close the quantity, plus 6. Look at the left-hand side. If I add 5 and 6 together first, I get 11. And I can add that with the 2. On the right side, what if I added the 2 and the 5 together first? I would come up with 7, and then add that with 6. 2 plus 11 is 13, and 7 plus 6 is also 13. So this means that when you have a list of numbers and they're all added together, you can add them in any order and still get the same answer. The commutative property of multiplication says that A times B is the same thing as B times A. In other words, if I had 2 times 6, that's the same thing as 6 times 2. In either case, it's still going to be 12. The associative property of multiplication says that if I have A times the quantity of B times C, I can do the quantity of AB, close the quantity, and then multiply by C. In other words, if I had 5 times the quantity of 2 times 6, I could do the quantity of 5 times 2 first, close the quantity, and then multiply by 6. Over here in the parentheses, 2 times 6 is 12. But on the right hand side, I'm doing 5 times 2 first, that's 10. And then I could multiply that by 6. However you do it, the answer is still going to be 60 on both sides. So when you have a list of numbers multiplied together, you can multiply them in any order and still get the same answer. If I have 6 plus 3, but then reverse the order to make it 3 plus 6, I still get the same answer, and that is the commutative property of addition. If I'm going to add 2 and 5 together to get 7 and then add it to 4, I should be able to add 5 and 4 together and then add it to 2. Either way, I will get 11 for the answer, and that is the associative property of addition. Sometimes you will have to simplify these a little bit before you can come up with the property that's being illustrated. For example, 3 times 2. That is something that you have to do first because it's multiplication. You have to do that before addition. But notice where the 3 times 2 is at. It's on the left-hand side there, but on the right-hand side it moves over to the right. Look at the sign. Plus, plus. These items that you are adding together have changed position. So when you're adding 2 items together, I know there are 3 numbers there, but you can consider them 2 items because you're multiplying 3 and 2 just to get 1 item. When you shuffle around 2 items with addition, that is the commutative property of addition. Notice that you have 3 multiplied against a quantity on each side. Does that 3 change position at all? No. Does the quantity change position? Are the parentheses still in the same spot? Yeah, they're still there. What's different from the left to the right? The 2 and the 4 traded spots. Right here, you have 4 times 2. But here, you have 2 times 4. That is the commutative property of multiplication. When you're adding 3 or more items together, you can add them in any order. So notice you're doing 6 and 2 first here, but over here it's 5 and 6. Either way you do it, you're going to come up with an answer of 13. That is the associative property of addition. Let's replace a and b with 3 and 4. So instead of a squared, we will have 3 squared. And instead of 2b, we will have 2 times 4. Instead of minus 3a, we'll have minus 3 times 3. So that is 9 plus 8 minus 9. That's 17 minus 9, which is 8. B.